Okay, so is everyone here? Sorry for being late, I was having a call. Okay, shall we start the second session? Okay. So the second session is going to be um, about frame analysis, and we'll learn how to do that using different software. So here we have SkyCiv, robot structural analysis, frame analysis, and then Prokon once again. So going for SkyCiv. Okay. We open SkyCiv. Now what we can do in SkyCiv, we can go for structural 3D. Okay, we can go for structural 3D, or we can go and use truss or frame. Okay, so 2D truss or frame. This is going to have more elements. This is limited number of elements. Sorry. Okay, so going for, let's say, for a frame, since we don't want to use a lot of elements. So SkyCiv frame 2D launch. Okay, continue with 2D or going for 3D? No, continue with 2D only. Okay, so this is how it look like now. Um, Nodes, members, blades, supports, and then loading, point load, moment, distributed load, area load, pressures, self weight load, combos, and it goes. Nodes are the points, so I need to know how many points are there. Okay, so let's say that they want to analyze a frame that is having a length of two frames, two equal frames, okay, which are having a span of 5 meter and a height of 3.5 meter. So what I need to do, I need to specify the coordinates first. So the coordinate is 0 and 0, so it came for me. And then, okay, so let me just, okay, what I want to do, I want to have, okay, I want to have two frames. Okay, so two frames. Two frames. This is having a span of 5 meter. Let's say this is having a span of 5 meter as well. The supports are fixed, and then the height is 3.5 meter. So I need to know how to read the coordinates. So this particular coordinate now, this coordinate is going to be 0 and 0. Now we say, okay, we say this having a span of 5 meter. This is having a span of 5 meter as well. The height here is 3.5. Okay. So I need to know how to read the coordinates. Now this is 0 and 0, x and y. So this point now, this point is going to be, we moved 5 in the x, we didn't move in the y, so this is going to be 5 and 0. Here we have it as 10 and 0. Okay. Why 10 and 0? Because we moved 5 first and then we moved another 5. We didn't move in the y. Now when it comes to these 3 points, this was 0 and 0, and we moved up by the value of 3.5 meter. So this is going to be here, this is going to be 0 and 3.5. 0 in x, 3.5 in 1, and then this point x is 5, so I just write it as 5. Y we have moved from 0 to 3.5, so 3.5, and then this point is going to be 10 in x, 3.5. Okay, so these are the 6 points that I need to enter. Okay, so if I go here, 0 and 0 we have input already, 5 and 0, so x is 5, and then we have x is 10, so I have input 3 points, 0 and 0, 5 and 0, 10 and 0. Okay, these are the points, 0 and 0, 5 and 0, 10 and 0, and then we have 0 3.5, 5 3.5, and 10 3.5. So I can copy all of these, paste them here, and change this one to be 3.5 each. Now what happened? I have 6 points, 0 and 0.
Stop.
Yes.
قطع السلايد.
Okay. So you were not seeing anything from the beginning? Shall I repeat it? Everything was not. So nothing is appearing. Okay. Okay, I repeat. Okay. Okay. So now everything is, you can see now. Now you can see. Okay. Okay. So I want to go and do a frame, two typical frames. Each one is having a span of 5 and having a height of 3.5. Now for me I need to specify the coordinates. So this is what I was saying. This is having a coordinates of x and y, so 0 and 0. This is 5 meter span. This is 3.5 meter height. So from here to here, 0 and 0. I moved 5 meter in x, so this is 5 and 0. And then I moved another 5 in x, so this is 10 and 0. Now for these 3 points, this was 0 and 0, 0 in x, 0 in y. I went up by the value of 3.5, so 0 and 3.5. Here once again I went up by 3.5, so 5 to 3.5. 10, 0, we are going up by 10 to 3.5. Okay, so these are the 6 points that I need to input in the software. Going to SkyCiv. Okay, going to SkyCiv. Going for SkyCiv here. Okay, so we can see here these are the typical modules. We can click on more software. There is the structural 3D, and there is the 2D truss frame. You can go for launch. You want to use truss 2D, frame 2D, or structural 3D. The difference between truss 2D, frame 2D, and structural 3D, the structural 3D is unlimited number of elements and limited number of points. SkyCiv, truss, and frame are limited. So we'll go for the frame now since we are doing a small model. Click on SkyCiv frame, launch. Okay, do you want to continue with the 2D or 3D? Continue with the 2D. So we have nodes, which are the points, members, plates, supports, and goes on. We'll take each one separately. Going for the nodes. Now it will ask me what's the first node, second node, third node, and goes on. So my first node was 0 and 0. If you can see here, 0 and 0. So 0 and 0. Apply enter. Second point is 5 and 0, 10 and 0. So I'll just change 5, 10. Okay, so we have 3 points now, 0, 5, and 10. We want to do these 3 points, 1, 2, and then 3. So I can click here in the data sheet. I can see that this is 0, 0, 5 and 0, 10 and 0. I can see that The values are the same here, 0 and 0, 5 and 5, 10 and 5. The only difference is 0 and 3.5, 0 and 3.5, 0 and 3.5 in the y. Okay, so what I can do, I can copy these, Control C and Control V for paste. Now this should be 3.5, so I'll just click 3.5 here, okay, and then pull it down. Now what do I have? I have 0 and 0, 5 and 0, 10 and 0, which are these. And then I have 0 and 3.5, 5 and 3.5, 10 and 3.5, which are these. Okay, and then click on apply. Now you can see we have 6 points. We have 6 points here. And then after we drew the points, we need to connect them. So what are the connecting elements? I need to connect between these 2 points, one element, these 2 points, these 2 points, these 2 points, and then these 2 points. Okay. So we'll go for members. You need to connect between which member and which member. So I need to connect what's A, what's B, what's the starting, what's the ending. So I need to connect between one. You can see till 4. So this is the first element. 4 and 5, second element. 5 and 6, third one. 6 and 3, fourth one. Fifth one is going to be 5 and 2. So now we have the elements as exactly shown here. And then we need to apply the support. So we'll go to support. So I want which nodes to have the support. So 1 and then 2, comma 2. So it will choose 2 as well, comma 3. So it's choosing the 3 nodes. You can see here highlighted. I want it to be fixed support. So we have different types, fixed and then apply. So we have fixed supports in each one of them. After that we can put distributed load. We can put different loading as well. It's easier. Now going here, which member ID I want to have in member number 2. You can see that 2 has been highlighted, and member number 3, for example. So 2 and 3 I want here. Is it in the direction of X, the loading, or direction of Y? I want a vertical loading, so we need to take Y because X is horizontal. So Y. Is it in Y? This is start X. I'll leave it. Start end X. I'll leave it because we don't have horizontal here loading. We have vertical. Is it downward or upward? I want to have, for example, downward. So I'll just write it as 5 and then -5. And then here start position and end position or finish position is the length of the URL, whether you want it to be full. If it's full, then it's from 0 to 100%. If you want it only like half, then 0 to 50, and it will. So apply. You can see now loading came here for me. Now I want another load, but in member number 1, for example. Click on member number 1. Start X. Is it an X? Yes, I want it to be an X. X positive. So for example, I want it to be starting at 0, ending at 10. Okay. And then click on apply. You can see that we have from 0 ending at 10 for this element only. Okay. And then we can go and apply other loading. Like for example, we can go and apply point load. Do you want it to be a node or a member? For example, we can have it on a member. Member ID, I want to be having a point load, for example, here, or let's say here, representing a wind load. So for example, member number 4. Position along member, I want it in the middle, so 50%. X magnitude, do you want it in X or Y? I want it to be horizontal, going to the left side. Since it's going to the left side, it's going to be negative. X positive is going right, X negative is going to the left. Okay, so minus, for example, -10. And then apply. You can see in X direction we have a new load going left, so it's negative. We can put on a node اللي هي النقطة, the points. Member are the lines, which are the beams and the columns. So for example, I want another one on a node. So which node I want it to be? Node number 6. I click on it, click or right number 6. And I want as well the same loading here. So I'll just click -20 and then apply. You can see two loads are there. One of them is on a member, another one is on a name. Okay. So we have done different loadings. We have finished from here. We can go for solve. Okay. So linear static analysis completed. Uh, Reactions. So you can see these are the reactions for the for this frame. Okay. We can remove whatever we want. For example, I want only okay. 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 So I want Fy. So these are the vertical reactions. I want Fx. So these are the horizontal reactions, and I want, for example, Mz. This is going to be my mode. Um, I don't want the reaction anymore. I want to see the bending moment. So this is my bending moments for this particular frame. Okay. Now you can see, of course, the bending moment is not going to zero here because the support is fixed. If we go and change the support condition here, okay, we can change the support condition from this is, for example, this is pin. I can copy this code, go here, and then all of these three keys them to be pin apply. And you can see all of them are pin. Go to solve. Okay. Now you can see the bending moment here is ending to zero because the type of support is pin, which cannot take bending moments. Okay, so this is SkyCiv in terms of modeling. It will take some time because you need to identify the coordinates, finding each coordinate. If you are having a bigger frame, uh, many frames, I mean, then it will take you time to find the coordinates and to input them in the software. Okay. Other than the SkyCiv, what options do we have? We have robot structural analysis, so we can go for robot structural analysis. Once again, we can go for SkyCiv. We can go for the library structure, and then we can go for typical structures or views of frames. We can go for a frame from here. Okay. So let's say that number of spans, I want the number of spans to be 3, for example. Span length is going to be 5 meter. How many stories? 3. You can see that we have 3 stories here. Okay, we have 3 stories, and then the story height, for example, is 3.5. Now this is going to save you a lot of time rather than going and modeling, for example, in robot structural analysis itself, or going uh, uh, for SkyCiv or other options as well. Okay. So now you can see that this frame came for us. We can go and input the loading and then finding the bending moment directly. Let's have a basic one, so it will not take us a lot of time. Just one second. Just one second. Somebody's calling. Okay, let's go for new project. Shell design. I want to have only one story. Okay, so typical. Going here once again. So I want it to be, for example, 3 spans, 5 meter each. Number of stories is 1. Then story height is 3.5. And then next, and then apply. So we have now one story, dimension is 3.5. How to make sure you can go for tools, dimension line. So this is 5 meter, this is 3.5 meter, and goes up. Okay. Now what I want to highlight here, okay, I want to go and have exactly the same thing, uh, but having it as a beam to illustrate for you something. Okay. Going for a beam. Number of spans, I want number of spans to be 3 as well. Span length is 5 meter. Insert, and then okay, so what we can do, we can start from x is equal to 20, this one. Okay. So what do we have now? Okay, well, this was 3.5. Just take it here, then I just repeat it. Okay, so number of spans, exactly I want the same thing. Number of spans is 3, span length is 5 meter, section leave it as it is, we don't want to consider the set weight insert. Now I want this one to be exactly in the same line. So for example, I'll start from 20, so they will not intersect with each other. So 20 in x, since 20 is away from 15, so 20, and I want it to be in the same height of the beam. So the height of that beam, the height here is 3.5, so I'll just keep this one to be 3.5. Uh, the other one, I don't need to, this should be kept actually 0, since it's 1, so 3.5, since it's okay. So now what do we have? We have a frame, okay, we have a frame which is having 3 spans of 5 meter, and we have a beam which is having 3 spans of 5 meter, and then of course we don't have the fixed support in the center. I mean internally we have the pin support. So now we want to differentiate between the bending moment and shear forces for the frames and the beam, for that they are same or not, whether we need to go and model our building as a frame or as a beam, and we'll see that. We'll see that thing. Now going for the loading, just put a load type. Let's just call it as dead for example, or general load or whatever name. Okay. Close. Going here to define the type of load. I'll define the value of the load. We want it to be node is a point load, bar is a line, surface is an area. Here we have line members, so we need to have as a bar node level point load, bar low UDA, surface is an area load like if it's a slab. So going for a bar, uniform load is in X or Y or Z. The load is going to be on Z because Z is vertical. Do we need it upwards or downwards? Here Z up, I mean Z is going up, so Z positive is up, Z negative is going down. Our load is going down, so minus, let's say the load is minus 10. So I want to apply now minus 10 here, here, and then we have minus 10 here. Okay. So what I have done, we can show the load from here, the value from here. Okay. So I have a frame and a beam which is having the same number of spans, the same span length, and I want to cross check whether the values are going to be the same or not, and which one is going to be correct to be modeled in reality or not. I mean in reality. Okay. Now you can see that the dimensions are exactly the same. Okay, we just hide the loads now. We'll go and go to loads, load table. We'll just delete the self weight, the first one. Remaining is the general loading, which is -10. Okay. And then calculate. Two things came for you here. One is the parameters, so that's fine. It doesn't matter. You can go and identify the type of state. For example, if we go and change it to S355, okay, for example, and then calculate, you can see that that warning will be going. Okay, that warning which is related to the material, since the material was not identified, was kept steel only, without identifying the grade. So here, separate structure because these are separate. So it's not an error, but it's telling you that these are not connected. Whether you want them connected or not, it's up to you. Okay. So now we want to go and check the results. So diagram for bars, going for the moment values. Both of them are exactly taking the same load, the same spans. Checking the bending moment value. Now you can see these are the bending moment condition. Now, by illustrating, you can see the bending moment at the support is taking more bending moment than the support, the column beam junction here. Okay, why? Because certain moment of the beam is taken by the column, which is the real action which is happening in reality. Okay. Now, if you are modeling your building as a beam, not as a frame, it means that you are not transferring any moments for the columns, and that's a wrong thing in case of having a concrete monolithic construction. Means beams and the columns are connected with each other. Okay. Now we want to see the values. We can go for parameters from here, parameters, or we can go from here, parameters, and then labels. We can differentiate between negative and positive. So differentiator. Now what you can see that we have different values. Okay. We have different values. So here we have 20.83, 20.83, and then it goes on. Here 23 and 23, and this is going to be around 14. This is 14 and this is 14. Span moment is 12.49, use 10, and it goes on. Okay, so you should be analyzing your building as a frame, not as a beam. Once again, that's referring to the moment transfer. Your column should be taking a moment. It's not considered. Your element is not considered to be simply supported. So, or a fully simply supported, so that the column will not take any moment. Okay. And once again, this is just to show you how to do the frame in robot structural analysis. Once again, it's very simple. Uh, you need to go for the library, choosing the shape that you want, whether you want it as a beam or a frame or a warehouse, whatever shape you want. Inputting number of spans, how many spans are there, inputting the length of each span, number of stories. For example, I want 100, then I need 100. Story height you can specify as well. So it will save a lot of your time rather than going to, for example, robot or ETABS or STAD and going to manually do the grids and then beams and then columns and so on. Okay, going for the third option, which is 2D frame analysis. So going for the 2D frame analysis. Okay, so here we don't want a beam, we want a frame. Once again, you can choose the material. I don't want steel, for example. Going for import, choosing the DS concrete, and you can choose whatever grade. For example, you want to use C35, so C35 insert, and then OK. The length of the beam, for example, is going to be 6 meter. I want it to be 5, for example. Uh, the story number of stories, I want number of stories to be 3, and then story height is 3.5, for example. Do you want the supports to be hinged or fixed? I want it to be fixed. You can see everything is changing here. Okay, so it's cross section of the column. I want it to be rectangular. Okay, import from material. If it's other than rectangle, then you can choose from the library. Here you can choose the VS Code as well, and choose universal column, universal beam, and whatsoever. Okay, for us, let's say that it's a rectangle, and I want to use 200 into 400. So C 200 to 400, and then for the rectangular section for the beam, I'll choose 200 and 400 once again, and just write it to be B for B, 200 to 400. Okay, and then the vertical loads on the beams, for example, I'll just keep them to be 15. So 15 is typical here. Click on here. So this will be coming for you. Okay, so this will be coming for you, your frame with the loading, with the spacing that you have saved. You can see that this is from 0 to 5, and you can see that this is from 0 to 3.5. And we can run the analysis. Okay, you can see the deflection, you can see the reaction here, the axial force that's referring to how much the reaction here. You can see uh, this column was taking 337.5, this column is taking 75, this column is taking around 112.5. So if I want to design, for example, the columns in this particular example, I can take 112.5 and design it in Excel. So this is the first thing that I need, which is 112.5, and I need to have the bending moment. So the bending moment here, for example, 11.95 for the top moment, 6 for the bottom moment for the column. Always when it comes to be fixed, we have top column and bottom column for the, top moment and bottom moment for the column. Okay, so these are this is how to model a frame in 2D frame analysis. It's very simple. It's for uh, typical building. It does not take time. It will give you the results within 2 to 3 minutes, uh, which will save a lot of your hand calculation or modeling in any other software. Okay, going for the last option, that is Prokon. So I need to click on Prokon. This is Prokon, and once again, you can download the trial version of Prokon. Okay, now going for Prokon, we have different options here. We can go for analysis. For the design, we are going to use Prokon. For tomorrow's lecture, most probably we are going to use Prokon, and we are going to use concrete a lot. But anyhow, for the main time for modeling, we can go for analysis, and then we can go for frame. Um, okay, okay. So here, what happens? They have wizards as well. The wizards are the most easy things in the what you call in the software. Uh, it means that there is a model which is ready in the software. The only thing that you need to change the inputs. So, for example, if I want to go and have an RC building frame here, click here. It will tell you a number of columns. Just see what is happening here. Okay. So number of columns in X, we have 1, 2, 3, 4. For example, I want it to be 5. So just click 5. You can see now the number of columns here are going to be 5. Number of columns is 4. On the other side, I want it to be 3. So I'll just click 3. So now there are 3, and then there are 5. Distances are 5.5, 6, 7, and then 6. Now This is the spacing for the first direction. This is the spacing for the other direction. So what I put here, I can write, for example, 5.5. If I write it 5.5 means everything is going to be 5. If I write 5.5, 5.5 and then comma 3.5, it means that first one is 5.5, second 3.5, and then the others will follow the last one. Now if I write 5.5, 3.5 and then 7, okay, so 5.5, 3.5, 7, and then the last will follow the last one. Okay, so 6 meter here. No, I wanted 6 meter and then I want 5 meter. Okay. Number of floors, 50 floors. Or number of floors is 4. For example, I want one only or two. You can see now what's happening. The number of floors are increasing. Floor height, you can see that the first one is 3.8. So for example, I want it to be, first one is 4 meter, second is 3.5 and above. So what happens here? You can see first one is 4 and then 3.5 meter, and then we can increase and you can see what's happening here, 4, 3.5, 3.5, and that's going on. Okay. Fixity, that's fixed in x and y and z. It means a fixed grade, a fixed support grade of concrete for the column. You can keep it as C25 or 30 or 40, 40 for example. Concrete column size, that's for the corners. So any corner. So for example, I want the corners to have, for example, 0.4 and 2.4, and then the edges, you can specify them as well, how much. The slab thickness, for example, I want it to be 0.3. Grade of the slab is 40. But this wizard is for a flat slab where beams are not there. You can see that there are no beams in the layout. Okay. And you can see the grids. Is there any cantilever? Now you can see that there is a cantilever going outside here, cantilever going outside here. So if there is any cantilever, what's a cantilever? So for example, I want the cantilever to be 0. So there is no cantilever. Keeping them, for example, as 1, you will see a cantilever of 1 meter on both sides. Okay. Now, loads, you can put the loads on the slabs directly. So that load, live load, for example, minus 5, and then live load, for example, minus 3, and then wind load now I don't want. Okay. And then click on OK. You can see this has been shown for you, and you can see the 3D here where we are having the slabs and upper columns in a flat slab system, and you can see you can go for the analysis. Okay, you can go and see for the analysis, and you can see, for example, the forces. You can see the values of the loading on each and every column. You can go and see it. The same thing for the slab. Normally it takes time for the slab. Okay. That's regarding the modeling in Prokon. Okay. Once again, you can choose. You can choose, for example, you want to go for a rectangular column. Okay. Normally it takes some time. Anyhow, normally you can click on the element and then design it. It will be taken in design of Prokon. Prokon will take it directly and then try to design it. Okay. Okay, but normally it takes some time till that Prokon reads it. Anyhow, so this is the modeling in Prokon. Where uh, it's good for flat slab system. Okay. Other things that you can do with Prokon as well as just to illustrate for you. Uh, Other things like, for example, you have circular reservoir, so you can have a tank. Yeah, just not change anything and just show you. So this is the tank which carries the water. So directly I can change only whatever I want, the diameter, the height, and every other thing. I can go for what you call a dome, a spherical shell. For example, I want to change the height, the diameter, whatsoever. Click. Okay. If I need to change the material from your material, for example, 40. Okay. Okay. So for example, so this is my node, and then you can get, after putting the loading and everything, you can get the trusses and then design for the dome. So a lot of things are there, a lot of options are there for you. You can choose whatever you require, and then have that particular element. Okay. So once again, some examples are there, truss and whatsoever. You can go for a truss as well. Input the trusses, input the loadings, and then it will give you everything. Okay. So you can see here there are different softwares which are having easy things inside them, which will solve our problems in no time approximately, compared to if we go and model them in large structural software like robot, ETABS, STAR, or other things like we have seen how much time was required to model a Doom. If I go and model myself that Doom in robot, it might take half an hour. Okay, so it takes some time to go and model in large software. But if you are using the general wizard which is available inside that particular software, then it will save a lot of your time. Once again, the intention was not to go in details and explain for you how would you use the software, but just to show you that there are a lot of options which you need to see. So whatever I'm trying to tell you, I'm trying to tell you that you shouldn't stick to one software. You should know as many software as possible, and you need to know for this particular job which software is going to give me the best option within the minimum time. Okay, so we have finished the second session. If you have any question, I'll be gladly answering your question. If not, we'll have 5 minutes break, and then we'll go for session number 3.